Namaste and welcome to the tutorial on similarity. Let's consider the definition for similarity. Let's consider A and B are square matrices for which there exists an invertible matrix P. Here P is change of basis matrix such that B is equal to the product of P inverse with A and P. Then B is said to be similar to A, or B is said to be obtained from A by similarity transform. Hence the theorem based on this concept says that if A and B are similar matrices, then A and B are always viewed as the matrices of the same or a single linear transformation with respect to the difference basis. That means, let's say if A is representing a matrix relative to the basis S for the mapping F, then for the same mapping B represents a matrix relative to the basis S dash. So now let's consider some problems based on the similarity. So here we are having a problem in which the matrix A is given and the change of basis matrix P is given to us, and we are supposed to find out a matrix B such that B is equal to P inverse into A into P. And also we have to verify the trace of B is equal to trace of A, and we have to find out, we have to verify whether the determinant of B is equal to determinant of A. So now let's go with the section A. So here first we will find out a matrix B. Matrix B is nothing but the matrix representation of a function relative to the another basis. So as we are already having a P, we will straightforward use this formula and construct the matrix B. So from the P we will find out the P inverse, and then we will find out the value for the B by using this equation. So this is the matrix B we got. Now we'll move to the section B. Here I have written the matrix B for the reference, as we are going to use it for the further calculations. So let's go for the verifying the trace of B is equal to trace of A. So trace is nothing but the sum of the diagonal element of any matrix representation of F. So here B represents, B is the matrix representation of F in one of the bases, and similarly A is also the matrix representation of F is in the another basis. So first we will find out the trace for B. So trace of B is nothing but the addition of this diagonal elements. So we will add 15 and minus 11, we will get 4. Similarly we will find out trace of A by adding the diagonal element of it, that is 2 and 2 plus 2. So that is also 4. So from these two equations we got that trace of B is equal to trace of A. Similarly we will find out the determinant of A and B, and we will verify whether they are same or not. So the determinant of B is nothing but equal to 5, and similarly we got the determinant of A is equal to 5. So from these two equations we got the result that determinant of B and determinant of A are equal. So you can self-try the problem based on the same steps that we have used just now. Thank you.